Dear students, welcome to my classroom. In the previous part of the chapter pair of linear equations in two variables, we completed solving all the problems in exercise 4.1 which are based on the graphical representation of pair of linear equations in two variables. And while solving that problems, we have some difficult cases like this. So see this graph. In this graph, the two lines are intersecting at 2.3 something and my 2.3 comma minus 0.8 something. So in such cases, it is difficult to denote the coordinates of the point of intersection of the lines represented by our equations. And also here we have one more case. See this one also. So here also the intersection point is 3.1 comma 1.3 something like that. Okay, so it is not suggestible that when the solutions are in decimals, isn't it? Because it is very difficult to plot the intersection point and denote the its coordinates, isn't it? So the graphical method is not suggestible for the linear equations whose solutions are in decimals. But how to solve in such cases? So we have one more alternate method to solve the linear equations in algebraic method. So let's see what is algebraic method. So in algebraic method, we have two methods to solve the pair of linear equations in two variables. First one is substitution method and the second one is elimination method. So let's see what is substitution method and what is elimination method. So take the first one, substitution method. So take any two equations, any two linear equations in two variables. So I am taking here 2x plus y minus 4 equals 0 and x plus 2y minus 5 equals 0. So take them as equation 1 and equation 2. So what to do while solving in substitution method? So in step 1, in one of the equations, express one variable in terms of the other variable. Say y in terms of x. So that is, in any one of these two equations, we express one variable in terms of other variable. That is x in terms of y or y in terms of x. So from equation 1, here we have y is equal to 4 minus 2x, isn't it? Here we are expressing y in terms of x. So let's see what is next step. In next step, substitute the value of y obtained in step 1 in the second equation. So that is, we have to substitute the value of y is equal to 4 minus 2x in equation 2. The value of y obtaining from first equation is to be substituted in second equation. So that is, we have to substitute y is equal to 4 minus 2x in second equation. So x plus 2 into 4 minus 2x minus 5 equals 0, because in second equation we have x plus 2y minus 5 equals 0 and we are substituting y equal to 4 minus 2x in second equation. So x plus 2 into y is 4 minus 2x minus 5 equals 0. And what to do in next step? So in step 3, simplify the equation obtained in step 2 and find the value of x. That is, we have to simplify this equation and to find the value of x. Okay, so x plus 2 into 4 is 8, plus 2 into minus 2x is minus 4x. So x plus 8 minus 4x minus 5 equal to 0. So that is minus 3x plus 3. 8 minus 5 is plus 3 equal to 0. And from this we can write minus 3x equal to minus 3. And from this we can write x equal to 1. So we got the value of x as 1. So in next step, substitute the value of x obtained in step 3 in either of the equations and solve it for y. So that is, we have to substitute x equal to 1 in either 1 or equation 2. So here I am substituting this value in equation 1. So if x equal to 1, what will happen? 2 into 1 plus y minus 4 equal to 0. That is 2 plus y minus 4 equal to 0, and y minus 2 equal to 0, and from that we can write y equal to 2. So here we got both the values of x and y. And in next step, check the obtained solution by substituting the value of x and y in both the original equations. So that is, we have to check whether our solutions got are right or not. So substitute these values in both the equations. That is, x equal to 1 and y equal to 2. Substituting these two values in equation 1, we get 2 into 1 plus 2 minus 4, which is equal to 0. So LHS equal to RHS. And also by substituting in equation 2, what we got? 1 plus 2 into 2 minus 5, which is equal to 0. Again we have LHS equal to RHS. Okay, so like that our solutions are x equal to 1, y equal to 2. So we solve the pair of linear equations in two variables in substitution method in this procedure. Okay, so first we express one variable in terms of other variable, and after that we substitute that value in either of given equations, and from that we get the value of one more variable. Okay, so let's see what is elimination method. So our second method is elimination method. Second algebraic method is elimination method. So in elimination method, so write both the equations in the form of ax plus by equal to c. That is, we have to write both the given equations in the form of ax plus by equal to c. So I am taking two equations in this form. So first one is 3x plus 2y equal to 11, and after that 2x plus 3y equal to 4. So take the equations as equation 1 and equation 2. So after that, make the coefficients of one of the variables, say x, equal by multiplying each equation by suitable real numbers. So what to do we here? We have to make either of coefficients of either of variables x and y to equal by multiplying the equations by suitable real numbers. Usually we make the coefficients of x equal, and while making the coefficients of x equal, we make their coefficients equal to their LCM. That is, here we have the coefficients of x as 3 and 2, and we equal the coefficients to their LCM. That is, LCM of 3 and 2 is 6. So we make both the coefficients of x to equal to 6. So for that, we multiply the first equation by 2 and multiply the second equation by 3. So multiplying equation 1 by 2, we get 2 into 3 is 6x, 2 into 2y 4y, 2 into 11 is 22. That is 6x plus 4y is equal to 22. And multiplying equation 2 by 3, what we get? 3 into 2x is 6x plus 3 into 3y is plus 9y is equal to 3 into 4 is 12. That is 6x plus 9y is equal to 12. And in step 3, if the variable to be eliminated has the same sign in both the equations, subtract one equation from the other to get an equation in one variable. If they have opposite signs, then add them. That is, here we have coefficients of x are equal and their sign is, both the sign is positive. So in this case, we subtract the equations like this. While subtracting the equations, we change the signs of coefficients in second equation. So I am changing the coefficient of 6 as minus, coefficient of x as minus, and also coefficient of y as minus, and the constant also minus. So now by cancelling these two, 6x minus 6x and 4y minus 9y is minus 5 is equal to 22 minus 12 is 10. So minus 5y is equal to 10. And in step 4, solve the equation for the remaining variable. That is, we solve this simple equation which is in single variable. So y is equal to 10 by minus 5, and from that we can write y is equal to minus 2. So after that, in step 5, we substitute the value of this variable in any one of the original equations and we find the value of the eliminated variable. So here we have eliminated the coefficient x, that is eliminated the x term, and now to find the x term, that is to find the value of x, we substitute y equal to minus 2 in either equation 1 or equation 2. So by substituting this value in equation 1, what we get, 3 into x plus 2 into minus 2 is equal to 11. So from this we can write 3x minus 4 equal to 11 and 3x equal to 11 plus 4 which is equal to 15 and x is equal to 15 by 3 which is equal to 5. Okay, so here we got x equal to 5 and y is equal to minus 2. We can check whether these two values are right or not. So by substituting in one, 3 into 5 is 15 plus 2 into minus 2 is minus 4. 15 minus 4 is 11. So the first equation is satisfied. And in second equation, 2 into 5 is 10 plus 3 into minus 2 is minus 6. 10 minus 6 is 4. The second equation is also satisfied. So our solution is right. Okay. So in this way, by eliminating one variable, we find the value of another variable, and by substituting that variable in either one of the given equations, we find the eliminated variable also. Okay, so these two are the algebraic methods to find the variables x and y when the pair of linear equations in two variables are given. Okay, so now we are going to solve exercise 4.2, which are based on pair of solving the equations which are in two variables. Okay, so let's go for exercise 4.2. Okay, form a pair of linear equations for each of the following problems and find their solution. So there is, here some problems are given, and in these problems we have to form a pair of linear equations, and by solving the two linear equations we have to solve the problems. Okay, the first one is the ratio of incomes of two persons is 9:7 and the ratio of their expenditures is 4:3. If each of them manages to save 2000 rupees per month, find their monthly income. That's the problem. Okay, so let's solve this problem. So in this problem, it is given that ratio of incomes of two persons is 9:7 and the ratio of their expenditures is 4:3, and both are saving 2000 rupees per month. So, and we need to find their monthly income. So, a ratio of incomes of two persons is 9:7, and as the terms of ratio are 9 and 7, we can take them as 9x and 7x. That is, let the income of two persons be 9x and 7x. And also given that ratio of their expenditures is 4:3. So we can take the expenditures of the two persons be 4y and 3y. And we know that income minus expenditure is equal to savings. That is 9x minus 4y is the saving, which is equal to 2000 rupees, as well as 7x minus 3y is also equal to 2000 rupees. So then according to problem, so the income of first person minus expenditure of first person is equal to savings of first person. That is 9x minus 4y is equal to 2000. And similarly for second person, 7x minus 3y is equal to 2000. So take them as equation 1 and equation 2. Now for understanding, we are going to solve these two equations in both the methods, that is in substitution method and elimination method. So let's solve these two equations in substitution method. So while substituting in substitution method, we express one variable in terms of other variable. So from equation 1 we can write 4y is equal to 9x minus 2000, and from that we can write y is equal to 9x minus 2000 by 4. And now we substitute this value in equation 2. So the value of y obtained from equation 1 is to be substituted in equation 2. So substituting this value in equation 2, we get 7x minus 3 into, and the value of y is 9x minus 2000 by 4 is equal to 2000. So 7x minus 3 into 9x minus 2000 by 4 is equal to 2000. And now we can take 4 as LCM on left hand side. So now 4 into 7x is 28x minus 3 into 9x minus 2000 is equal to 2000. Now we can transform the denominator 4 to right side. Then we get 28x minus 3 into 9x is 27x, minus into minus plus 3 into 2000 is 6000. So 28x minus 27x plus 6000 is equal to 4 into 2000 equal to 8000. Now 28x minus 27x is x, and we can transfer this plus 6000 to right side. Now x is equal to 8000 minus 6000, which is equal to 2000. So we got the value of one variable, and let's substitute this value in either of given equations, that is either in equation 1 or equation 2. So now substitute y is equal to 9x minus 2000, substitute the value of x in y equal to 9x minus 2000 by 4. So y equal to 9 into 2000 minus 2000 by 4, because we got the value of x as 2000. Now y equal to 9 to the 18,000 minus 2000 is 16,000 by 4, which is equal to 4,000. So their incomes are 9x and 7x. 9x and 9 into 2000 and 7 into 2000, because x equal to 2000. So that is 18,000 rupees and 14,000 rupees. So the incomes of the persons are 18,000 rupees and 14,000 rupees. Actually here no need to find the value of y, but we are finding the value of y also here. And now let us solve this problem in substitution method, elimination method. So in elimination method, we make the coefficients of either of the variables x and y. So if we want to make the coefficients of x equal, then their coefficients must be the LCM of 9 and 7, that is 63. And to get 63, we have to multiply the equation 1 by 9, and to get 63 in second equation, we have to multiply the equation by equation 2 by 9. That is, we have to multiply the equation 1 by the coefficient of x in second equation, and we have to multiply the equation 2 by the coefficient of x in first equation. Okay, so here equation 1 into 7 implies 7 into 9x is 63x minus 7 into 4y is 28y is equal to 7 into 2000 is 14,000. That is 63x minus 28y is equal to 14,000. And similarly, equation 2 into 9 implies 9 into 7x is 63x minus 9 into 3y is 27y is equal to 9 into 2000 is 18,000. Okay, now let us solve these two equations. Okay, so if in the equation so formed, if any one of the variable, if the coefficients of any one variable are equal, then we can solve them directly without multiplying any real numbers. Okay, but here in first equation the coefficients of x is 9, and second equation coefficient of x is 7. In first equation coefficient of x is 9, and in second equation coefficient of x is 7. And in first equation coefficient of y is minus 4, and in second equation coefficient of y is minus 3. That is, neither the coefficients of x and nor the coefficients of y are equal. That's why we are making the coefficients of equal by multiplying them with suitable real numbers. And now let us solve these two equations. So here the coefficients of x are 63 and 63. That is, both are of same sign. That's why we are subtracting these two equations. So while subtracting the equations, we change the symbols in second equation. Now 63x minus 63x will be cancelled, and now minus 28y plus 27y equal to minus 5 is equal to 14y minus 18,000 is equal to 14,000 minus 18,000 is minus 4,000. That is, minus y is equal to minus 4,000, and from this we can write y is equal to 4,000. And let's substitute this value y equal to 4,000 in either of the equation 1 and 2. So let's substituting this value in equation 2. We get 7 into 4,000 minus 3y is 7x minus 3 into 4,000 is equal to 2,000. So 7x minus 3y equal to 2,000, and by substituting y equal to 4,000, 7x minus 3 into 4,000 equal to 2,000. That is 7x minus 12,000 equal to 2,000, and from that we can add 7x equal to 2,000 plus 12,000, which is equal to 4,000, and from that we can add x equal to 14,000 by 7, which is equal to 2,000. Okay, so now the value of x equal to 2,000 and the value of y equal to 4,000. Now their incomes are 9x and 7x. That is 9 into 2000 minus and 7 into 2000, which are equal to 18,000 and 14,000. So in this way we can find the values of x and y in elimination method. Okay, and in forthcoming problems we solve the problems in either substitution method or elimination method. Okay, now let's go for second problem. The sum of a two-digit number and the number obtained by reversing the digits is 66. If the digits of the number differ by 2, find the number. How many such numbers are there? That's the question. So here it is given that we have a two-digit number, and if we reverse the numbers, we obtain one more number. If we reverse the digits of the number, we obtain one more number, and the sum of the two numbers is 66. And also given that the difference of the digits in that number is 2. So using these two hints, we have to find the number. So we know that in a two-digit number, there is a digit in units place and there is a one more digit in tens place. Okay. So now let the digit in units place be x and the digit in tens place be y. For example, take a number 63. In the number 63, digit in units place is 3 and digit in tens place is 6. So we can express 63 as 10 into 6 plus 3. That is 10 into digit in tens place plus digit in units place. So the number is 10 into tens place, digit in tens place, that is y, plus digit in units place, x. So the number is 10y plus x. And if we reverse the digits, then digit in units place goes to digit in tens place, and digit in tens place goes to digit in units place. So then the number obtained by reversing the digit is 10x plus y. Now it is given that the sum of these two numbers is 66. So then according to problem, 10y plus x plus 10x plus y is equal to 66. Now x plus 10x is 11x, 10y plus y is 11y. So 11x plus 11y is equal to 66. And we can take 11 common on left side, 11 into x plus y equals 66, and can transfer 11 to right side, that is x plus y equal to 66 by 11, which is equal to 6. So take this equation, x plus y equals 6, and also it is given that the digits are differ by 2, and we don't know the bigger digit and we don't know the smaller digit. So if we consider x as a bigger digit, then x minus y is equal to 2, because the difference between the digits is 2. So take these two equations as equation 1 and equation 2. So let us solve these two equations in elimination method. Substitution method. From equation 1 we have in equation 1 we have x plus y equals 6, and from this we can write x equal to 6 minus y. Now we have to substitute this x equal to 6 minus y in equation 2. Okay, so substituting this value in equation 2, what we get? In equation 2 we have x minus y equal to 2. So, and we are substituting x equal to 6 minus y. So 6 minus y equal to 2. That is 6 minus 2y is equal to 2, and minus 2y is equal to 2 minus 6. That is minus 2y is equal to minus 4. And from this we can write y is equal to minus 4 by minus 2, which is equal to 2. And we have x equal to 6 minus y. So we can substitute y equal to 2 in x equal to 6 minus y. Now we have x equal to 6 minus y, and from this we can write 6 minus 2, because we got the value of y as 2. Now x equal to 4. Okay. Now we have x equal to 4 and y equal to 2. Then required numbers are 10x plus y and 10y plus x. And if we substitute x equal to 4 and y equal to 2 in these two numbers, we got 10 into 4 plus 2 and 10 into 2 plus 4. That is 42 and 24. So we have two such numbers in this problem, and the two numbers are 42 and 24, and we can check these solutions according to given problem. 42 plus 24 is, if we take 42 and the sum of digits is the difference of digits is 2, and the number obtained by reversing digits is 24, and 42 plus 24 is 66. And in same case 24 also, 24 plus 42 is 66, and the difference of the digits is 2 minus 4, 4 minus 2 is 2. Okay, let's go for third problem. the larger of two supplementary angles exceeds the smaller by 18 degrees. Find the angles. That's the question. Okay. So here there are two angles which are supplementary angles, and we know that the sum of supplementary angles is 180 degrees, and it is given that the larger angle is exceeds the smaller angle by 18. So here we have two hints. One is the sum of angles is 180 degrees, and the larger angle exceeds the smaller by 18 degrees. Okay, so in given two supplementary angles, let the larger angle be x degrees and smaller angle be y degrees. Now, according to problem, the x and y are supplementary angles. So we can write x plus y equal to 180 degrees. Okay, and also it is given that larger angle x exceeds the smaller angle y by 18. That is x equal to y plus 18. Okay, x equal to y plus 18. So take it as equation. From this we can write x minus y equal to 18. Take it as equation 2. Now we can solve both the equations in elimination method. So let us write both the equations here. X plus y equal to 180 and x minus y equal to 18 degrees. Here we can solve these two equations directly, because here we have the coefficients of x as 1 and coefficients of y as 1 with different signs. So we can either add these two equations, or we can subtract these two equations. If we add two equations, then y will be eliminated, and if we subtract these two equations, then x will be eliminated. So we can add or subtract. So here I am adding the equations. So when we are adding the equations, no need to change the signs in second equation. So now plus y minus y will be cancelled, and now x plus x 2x is equal to 180 plus 18 is 198. So we got 2x is equal to 198 degrees. And from this we can write x equal to 198 degrees by 2, and that is x equal to 99. So we got the value of x as 99 degrees. Okay. Now substituting this value in equation 1, what we get in equation, what is equation 1? X plus y equal to 180 degrees. So if we substitute x equal to 99 degrees in equation 1, 99 degrees plus y equal to 180 degrees, and from this we can write y equal to 180 minus 99 and is equal to 81 degrees. So the larger angle x equal to 99 degrees and the smaller angle y equal to 81 degrees. So the angles are 99 degrees and 81 degrees. Okay. And now let us solve the fourth problem. So large description here. The tax charges in Hyderabad are fixed along with the charge for the distance covered. Up to first 3 kilometers you will be charged a certain minimum amount. From there onwards you have to pay additionally for every kilometer travelled. For the first 10 kilometers the charge paid is 166 rupees. For a journey of 15 kilometers the charge paid is 256 rupees. And first one, what are the fixed charges and charge per kilometer? And in second one, how much does a person have to pay for traveling a distance of 25 kilometers? Okay. So in this problem it is given that the tax charges are described here, that up to first 3 kilometers we have to pay a certain minimum amount, and after that for every kilometer we have to pay additional amount. And according to this condition, for the first 10 kilometer the charge paid is 166, and for a journey of 15 kilometers the charge paid is 256 rupees. And using these two hints we have to find the fixed charges and charge per kilometer. After finding that, we have to find the charge for traveling a distance of 25 kilometer. Okay, so take the first one. Let the fixed charge be X rupees and the charge for every additional kilometer be Y rupees. Okay, now according to problem, what is given, what hints are given here? For 10 kilometers the charge paid is 166 rupees, and we know that up to 3 kilometers certain charge X rupees, and for remaining 7 kilometer we have to pay Y rupees per each kilometer. That is, for first 3 kilometers X rupees, and after remaining 7 kilometers per each kilometer Y rupees. So in that way we have paid 166 rupees, that is X plus 7Y is equal to 166. Here X is the fixed charge and Y is the charge per kilometer. When we travel 10 kilometers, up to first 3 kilometers X rupees, and after for remaining 7 kilometers Y rupees per kilometer. So in that way X plus 7Y is equal to 166. And for the journey of 15 kilometer, up to 3 kilometers X rupees, and for remaining 12 kilometers Y rupees. In that way X plus 12Y is equal to 256 rupees. Okay, so X plus 12Y equal to 256 rupees, and take the X plus 7Y equal to 166 as equation 1 and this one as equation 2. And now here we have the coefficients of X same 1 1. So by subtracting these two equations we can eliminate X and we obtain the value of Y. Okay, so solving equations 1 and 2 directly without multiplying any real numbers. So X plus 7Y equal to 166, X plus 12Y equal to 256. Here signs of X are same, so we have to subtract the equations. While subtracting the equations we have to change the signs in second equation, and now X minus X will be cancelled, and 7Y minus 12Y is minus 5Y is equal to 166 minus 256 is minus 90. So minus 5Y is equal to minus 90. From this we can write Y equal to minus 90 by minus 5, which is equal to 18. So we got the value of Y, and now substitute the value of Y in either of equations 1 and 2, and I am substituting the value in equation 1. And equation 1 we have X plus 7Y equal to 166, and we got the value of Y as 18. So we can write X plus 7 into 18 equal to 166. And now X plus 7 into 18 is 126, and X equal to 166 minus 126, which is equal to 40. So X equal to 40 and Y equal to 18. That is, fixed charge is 40 rupees and the charge per kilometer is 18 rupees. That is the solution of first one. And in second one, what we need to find, how much does a person have to pay for a traveling a distance of 25 kilometers. So while traveling 25 kilometers, for first 3 kilometers we have to pay X rupees, that is 40 rupees, and after that remaining 22 kilometers we have to pay 18 rupees per kilometer. So the charge for traveling a distance of 25 kilometer, the amount to be paid is X plus 22Y, because X is the charge for first 3 kilometers and Y is the charge for every additional kilometer. So the distance, the charge for distance 25 kilometers is X plus 22Y, and we got the values of X as 40 and Y as 18. So 40 plus 22 into 18, and 22 into 18 is 396. So 40 plus 396, which is equal to 436 rupees. So the charge for traveling a distance of 25 kilometers is 436 rupees. Okay students, that's the solution of this problem. Okay, very interesting problems. So just while forming the equations, we must be careful. Okay, and that's all for today, and in next class we shall solve the remaining problems in this exercise. Until then, see you, bye.